All right, calculus students, here we have the same square root function. This time we're going to be revolving it around the line x equals 1. So we're going to go ahead and draw a picture of what this looks like to remind us how to do this. So here we have the square root function from 0 to 4 at a height of 2 here, but then we're rotating it around over here at the line x equals -1. What we need to do is think about, it's the same area too, right? So we're taking the square root function, the same area as we did before. So it's the area under the curve. And so this is going to be the washer method. We have an outside radius, and that outside radius is going to start here at 4, and it's going to end here, way out over here at -1. So that's a distance of 5. So if you recall, the washer method starts off with a large radius squared and subtracts a small radius squared. So in this case, my large radius is going to be 5, and we're going to square that. We get 25. And then we're going to subtract the smaller radius. Now our smaller radius basically is going to start where this line would actually hit. So let me draw that in. So we're going to come across, and right here then, so from here to -1, that's my inner radius from a small radius. That's not as clear as the 5. So recall that we have y equals square root of x as my function. So if I square both sides, I get y squared equals x. And that ends up being then the x coordinate of that endpoint right there, left endpoint being y squared. So my radius then would be y squared minus -1, or y squared plus 1. So let's take our y squared plus our 1. That'd be y squared minus -1, y squared plus 1, and don't forget we need to square that. So we have outside radius squared minus inside radius squared, and we're going to integrate this, put a pi on the outside, don't forget the pi, and then we are going to go from 0. This time it's not 0 to 4 though, because we're using y's. It's going to be 0 up to 2. And I guess we'll make sure that we put a dy here right at the end. So we have dy. And then we're going to try to find this value, but we can just use a calculator on this problem. And when we calculate this on the calculator, we end up with an approximate volume of 113.935.